Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go. The agenda behind the basics of the engineering mathematics which we have been dealing so far is nothing to learn but the concept of the engineering mathematics from very scratch. Already the 15 number of videos have been made live, and there I discussed about very critical as well as small topics within the engineering mathematics. So forget about the things which we have learned earlier, just focus over this video. In today's video we are going to discuss over the concepts of the limits by taking the kinds of the numericals, because in last two videos we were discussing about the basic concepts of the limit, from where the concept of the limit has been pegged out, but so far I did not take much amount of problems based on the concept of the limit. And once you'll go back into the history of GATE examination, you will see there are abrupt amount of the questions has been appeared from this topic. So obviously the limit had been a very important topic as far as the GATE is concerned. That's the first thing, and that is why we are going to learn the concept of the limits with the help of few number of problems also. So let me straight away go back into the working board, and here we are going to learn the concepts of limits by few practical or numerical problems. Anyways, before straight away hop into the numerical aspects of the limits, let me focus over the important properties which are getting followed by the limits. So write down the properties which are followed by the limits. Let's take, you have a linear sum of the two different functions. Let's take, you had first function as f of x which have got multiplied with a constant a. You have got a second function g of x which have got multiplied with b, and in totality you are going to apply the limit x over a. So you can write somewhere if you want. The limit follows the linear property. What does that mean of it? That means exclusively you can apply the limit x tends to a over the f of x, and similarly exclusively you can apply limit x tends to a over the g of x. For the better understanding, you can do one thing, otherwise unnecessarily you make yourself. Let's take this has been taken as c. So here what's going to happen? So here I can take the a had been a constant, definitely the c would be taken out, and this limit would straight away would be applied over the f of x, and similarly would be applied over g of x. It's called the linearity property of the limit. Even instead the plus, if the sign would have been minus, obviously you can use even the minus sign. Even this concept is not only true for the addition as well as subtraction, even this concept is also true for the multiplication as well as division. So what I am going to take? I am going to take a next structure. There also we had the two functions. Let's take the first function had been f of x and the second function had been g of x, and here we had the multiplication between them. Here also, end of the day, we can get the result as limit x tends to a, f of x into of limit x tends to a, g of x, provided this should not be the case of indeterminate form. Yes, it should not be the case of the indeterminate form. In the same sequence, if we had the another pattern of the function where the two distinct function, let's take the functions had been f of x as well as g of x, has been divided by each other. There also the same fundamental can be applied. The limit can be exclusively applied over the f of x, and similarly can be applied over g of x. And again I expect it has not been in a form of indeterminate form. It is not a indeterminate form. Till this point, each and everything must be clear to all of us. Agreed? So what I am saying, in future whenever you have been dealing with the various other numeric values related to the limit, you may come across the various situation where you might be dealing more than one number of functions, where the functions had been added or subtracted together, had got multiplied together, had got divided together. In that case, how will you apply the limit obviously exclusively you can apply the limit over the first function that has been f of x, and similarly the second function over the g of x. Till this point each and everything must be clear to all of us. Now if you guys would be able to recall, probably 4 to 5 days back I was discussing about the indeterminate form. Precisely we had the 7 kinds of the indeterminate form, which starts from the division between zeros and zeros, division between infinity and infinity, then we were discussing about infinity minus infinity, and then we were discussing about 0 into infinity, and similarly we were discussing about 1 to the power of infinity, and then infinity to the power of 0, yes, and 0 to the power of 0, 0 to the power of 0. This 7 different kinds of the indeterminate form has already been seen probably 5 days back, and even I gave the bit reasoning why the 0 by 0, infinity by infinity, infinity minus infinity forms an indeterminate form, why we cannot exactly calculate those values. See what happens whenever we deal with the numericals related to the limits, many of the times this indeterminate form would be created. If you take few number of examples, like I can take an example, limit x tends to 0 sine x divided by of x. Once you will be feeding x is equals to 0, obviously it had been a division of the two different functions. Numerator had been f of x, and similarly denominator had been x itself. So taking the reference of the properties which we have been studying in the last slide, if you have got a ratio of a function f of x as well as g of x, and now the limit x has been moving towards a, what you can do exclusively you can apply the x tends to a towards numerator as well as denominator, provided the result should not be the indeterminate form. But once you'll see this problem, definitely once you'll feed x is equals to 0 and once you'll feed x is equals to 0, you will get to know they are making a indeterminate form. That is for sure. Similarly, in the same case, if we have taken another problem, let's take the problem had been limit x tends to maybe pi by 2 sine of x divided by of x. One thing had been quite sure, what it had been, sine of x is a continuous function, even x being a polynomial is going to be a continuous function. So what you can do over here, simply if you wanted to get the limit of sine of x when the x is reaching towards pi by 2, rather calculating the worth at pi by 2 minus or pi by 2 plus, simply you could have calculated the worth at pi by 2 itself. So you could have written numerator as sine pi by 2, and similarly towards denominator, as the value of x had been a continuous in nature, so rather calculating at pi by 2 minus or pi by 2 plus, you could have calculated at pi by 2 itself. So may I know what would have been the answer? The answer would have been sine pi by 2, that used to be 1, divided by of pi by 2, answer would have been 2 divided by 5. That is a perfect answer. So that's the difference what I am saying. Although the sine of x had been continuous at x is equals to 0, and even x had been a continuous at x is equals to 0, so rather calculating its limit straight away I could have fed x as 0 towards numerator and similarly x as 0 towards denominator, but end of the day the result what we are getting, no, they are being in the form of indeterminate form. So whenever you deal with the multiplication, addition, subtraction, try to understand the result should not fall into the indeterminate form. If it falls in the indeterminate form, there are several remedies how we would be able to deal with those problems. Could you understand what exactly I wanted to say? Similarly, in the same sequence, we can have few more outcomes. See, what are they? Like I am going to take limit x tends to pi by 2. Let's take the numerator function had been cos of x, and towards denominator we had the function as pi by 2 minus of x. Obviously cos of x as well as pi by 2 minus of x both had been a continuous function exclusively. As far as the cos of x is concerned, obviously it is gonna be a oscillating signal with the constant magnitude as well as frequency. Obviously it would be a continuous function. Pi by 2 minus of x, it's gonna be a straight line having a slope is equals to of -1, and yes, would be crossing through the y-axis at pi by 2. Had been a continuous function, but once you will be feeding x is equals to of pi by 2 towards numerator as well as denominator, the result had been 0 by 0, which is a form of indeterminate, Could you understand what I am saying? So what I would say to all of us, whenever you have come across this situation, and once you are feeding x tends to a towards numerator and denominator, if the result has not come into the form of indeterminate, simply whatever the result you get, that's gonna be your bestmost answer. Even this problem could have been even extended. Let me take another structure. structure had been limit x tends to a has been applied over a function f of x has been raised to another function of x which has been g of x, and this sort of problem do come repeatedly in the GATE examination. So what we are going to do over here, again the same methodology has to be used. What it is, limit x tends to a has to be fed with f of x, and then exclusively we can feed limit x tends to a with g of x. Again, the result should not be the form of indeterminate. If the result is not coming in the form of indeterminate case, obviously whatever the result you get, that would be the precise most result. For the time being, let's take an example. While feeding limit x tends to a fx, the worth had been 5, and similarly while feeding limit x tends to a g of x, the worth had been 2. So answer is simply going to be 5 has been raised to 2, the result would be 25. The result would be 25. Till this point, each and everything must be clear to all of us. Must be clear to all of us. See, let me focus over few number of indeterminate form, and we'll also try to understand how those problems would be dealt easily. The first method through which most of the problem gets solved, and that has been L-Hospital rule. L-Hospital rule. Keep in mind, when the L-Hospital rule has been applied, the L-Hospital rule has been applied when we deal with the indeterminate form. How many number of indeterminate form you have? 7 number of indeterminate form you have. But as far as the L-Hospital rule is concerned, it deals with only 2 of them. That has been 0 by 0 as well as infinity by infinity. Infinity by infinity. So many of the students used to have one doubt, sir, the L-Hospital rule can be used at any moment of time when we have any sort of indeterminate case. It's not like that. It has been specifically been applied over the 0 by 0 or infinity by infinity case. That's a different story together. With the help of logarithmic or ln, we can even convert the remaining 5 number of indeterminate form into this 2 form. Could you understand what I'm saying? Like if I take few number of examples, the first problem we had the limit x tends to 0, sine x divided by of x. Whether this problem can be solved using the L-Hospital rule or not, obviously, because once you will feed the x is equals to 0, the numerator becomes 0, even the denominator becomes 0. It had been a indeterminate form of 0 by 0. Even you can take the next problem like limit x tends to pi by 2, as we have been taking so far, and let's take it has been cos of x divided by of x minus of pi by 2. So again, I would ask the same question, whether this problem could have been solved with the help of L-Hospital or not. Obviously, sir, it can be, because again, it is forming the ratio of 0 by 0. So these are the different methodology through which we can solve the problem. In the same sequence, let me go forward. Let's take, I need to get the limit when the x has been tending towards infinity. Again, you had a complex function, not complex, that does mean that here the complex function. Let's take at numerator you had x square plus of 3x plus of 2, and at denominator you had x square plus of 5x plus of 15. One thing I had been quite sure what it is. Once you will be feeding x is equals to of infinity. Why I am saying x is equals to infinity? Because x square plus of 3x plus of 2, x square plus of 5x plus of 15 had been a polynomial, and once we have the polynomial, one thing is quite sure. What it is? One thing is quite sure, they would be continuous throughout its length, and as they have been continuous throughout its length, rather feeding its limit, simply I can feed the value itself. So once I will be feeding the value over the numerator as well as denominator, may I know what's the result we are getting at the numerator as well as denominator? That has been infinity and infinity. Here also L-Hospital rule can be applied. So let me focus how the L-Hospital rule gets applied. So many of us must be knowing how the L-Hospital rule gets applied. Let's take you have got a function which has been formed by the division of the 2 different functions. For the time being, it has been f of x as well as g of x. And once you feed x is equals to 0 over the numerator and denominator, we got to know what we are going to do. We are going to feed x is equals to a towards numerator as well as denominator. We got to know the result had been the form of indeterminate 0 by 0 or infinity by infinity. So what we are going to do over here, obviously we cannot get its determinate form. So what we are going to do over here, as per the L-Hospital rule, I can take its first derivative towards the numerator as well as denominator. Keep in mind, the differentiation has to be taken place with respect to the variable at which the limit has been applied. Because many of the times in GATE, I have seen deliberately what they do, they used to pump the two number of variables, not precisely two number of variables, among them one used to be the variable, another used to be constant. By default, they push the two different varieties, and many of the times the student used to have one doubt, so the differentiation has to be taken with what? The differentiation should always be taken with respect to the variable for which the limit has to be calculated. Variable for which the limit has to be calculated. Could you understand what I am saying? So here what I am going to do over here, again the limit x would tend towards 0. Again I would check whether it is going into the form of indeterminate 0 by 0 or infinity by infinity. If it is not going into the range of 0 by 0 or infinity by infinity, whatever the answer you have, that would become your perfect answer. Perfect answer. Otherwise, the same process has to be followed once again. May I know what does that mean by the same process? That means now you had to take its double derivative of the numerator as well as double derivative of the denominator, and this process has to keep move on. So till this point, probably each and everyone would have the clear-cut idea. Each and individual person would have the clear-cut idea. Yes, in the same sequence, let me take few number of problems. Let's take the first problem had been. This had been the first question of the day. Limit x tends to 0. Sine of x divided by of x. Obviously, it is one of the easiest problem, or the problem which we encounter many of the times while doing the analysis in the engineering mathematics, but still let me start with this problem. Tell me what would be the best most answer for this given problem. See what happens once you will be feeding limit x tends to 0 over the sine of x, and similarly once you will be feeding limit x tends to 0 of x. My dear friends, limit x tends to 0 of sine of x, can it be written as sine of 0? Try to understand what I am saying. Limit x tends to 0 of sine of x, can it be written as sine of 0? It can be written only and only if the sine of x is being continuous. If sine of x is being continuous at x is equals to 0, so the worth of sine of 0 minus, sine of 0 plus, and even sine of 0 would remain very same. So many of the times I have seen the student do one mistake. Straight away they are going to feed x is equals to 0 towards numerator and denominator without giving any of thought process. As the sine of x had been continuous at x is equals to 0, x which has been a straight line had been a continuous at x is equals to 0. So rather writing or rather putting its limit, you can simply put x is equals to 0 towards numerator as well as denominator. Could you understand what I am saying? Although you wanted to calculate the numerator and denominator in this sense, so again you had to find its left hand limit, you had to find its right hand limit, but as the sine of x as well as x has been continuous throughout its range, straight away I can feed the x as 0, and once I feed x is equals to 0, so rather calculating sine at 0 minus or 0 plus, simply you can feed sine of 0 itself, and similarly this process goes over here. May I know what's the result it had been? It had been producing 0 by 0, which had been an indeterminate case or indeterminate form. So what I would be doing over here, obviously first time we are going to apply the L'Hospital rule. What it states, you had to bring the limit and its values as it is. You had to perform the first derivative of its numerator, which had been cos of x, and similarly towards denominator, which would be plus of 1, and again you will try to feed limit x tends to 0 towards the numerator as well as denominator, Again I would be feeding limit x tends to 0 cos of x, and as it has been constant, obviously once you will be feeding x tends to 0. 1, what does that mean by 1? 1 had been a DC component, which is not changing its magnitude at all. So if you are reaching at x is equals to 0 from the left hand limit or the right hand limit, obviously you would be reaching to the same value, because many of the times I have seen the student says that the limit x tends to a of a constant value used to be a constant, but they exactly do not know what's the basic behind it. The basic remains very same, which we have been discussing so far. So again I can feed cos of 0 divided by of 1, and the result had been 1. And why the cos of 0 has been fed in? Because the cos of x had been continuous around x is equals to 0. around x is equals to 0. So there are several number of myths what we used to contain. Many of the students would see the limit x tends to 0 as the worth of sine of x at x is equals to 0. No, my dear friends, limit, that means you are approaching to x taking the left hand side or the right hand side. You did not reach to the exact value, you are just trying to reach that value. But here, as the sine of x as well as the x had been a what? Continuous function, that is why straight away I have fed the value as sine of 0 as well as 0. Even the same case was found with the cos of x as well as 1. Cos of x as well as 1. So just wanted to know till this point each and everything is clear or not? So probably till this point each and everything must be clear. Although we used to smash this problem in regular basis, but the fundamental must be true or must be known to all of us. Must be known to all of us. Till this point each and everything must be clear to all of us. Yes. In the same sequence, what we are going to do over here. Let me take the next question. The problem had been second. Problem had been second. Limit x tends to, deliberately I am going to make this situation. May I know which one? Deliberately I am going to make this situation, and that has been 1 has been raised to infinity. 1 has been raised to infinity. 1 has been raised to infinity. Let's take for that which arrangement has to be made. That has to be 1 plus of x has been raised to 1 upon x. Has been raised to 1 upon x. And once you will be feeding x tends to 0, as we have been discussing in the first slide, when you have a function f of x which has been raised to g of x, and let's take both of the function had been continuous, at least 1 plus x has been continuous at x is equal to 0. There is no doubt as such. There is no doubt as such. So obviously you can simply feed x is equal to 0. Once you will feed the x is equal to 0, definitely this becomes 1, and towards its power the worth is going to be infinity. And as we have seen earlier, 1 has been raised to infinity has been a form of indeterminate. Has been a form of indeterminate. Yes. Tell me how we will move forward from here. How we will move forward from here. Tell me, what would be your approach? See what I am going to do over here. 1 plus x which has been raised to 1 upon x has been taken as y. Obviously y has been function of x. So now what I am going to do over here, let me take the log natural both of the side. Log natural both of the side. So the result what we get in our hand has been sort of this. Sort of this. Could you understand what I am saying? And even end of the day, we can solve this problem when the ln goes towards right hand side. We have seen in the first video. Obviously the exponent would be created. Exponent would be created. Exponent would be created. How will you solve this problem? How will you solve this problem? See, if you forget about e for the time being, it had been a function 1 upon x ln of 1 plus x. And once you will feed the x tends to 0, obviously 1 plus x, where the x is tending towards 0 would make ln of 1. Ln of 1 used to be 0. And towards denominator side, you have got 1 upon 0, which is nothing but infinity. Which is nothing but infinity. Obviously, which is nothing but infinity. So may I know whether the new power of exponent is making a case of an indeterminate case or not, and that can be smashed with the help of L'Hospital or not. Obviously yes, we can just by taking the exponent. We made it sure once I'll be feeding x tends to 0, it would become ln of 0, so numerator would be 0 and similarly denominator would become 0. So now what we are going to do over here, we are going to apply the L'Hospital rule just into this part of the function. How we will apply it? We will take the differentiation of the denominator with respect to the x, that would be simply 1. That would be simply 1. And similarly, once we will take the differentiation 1 plus of 1 ln of 1 plus x, obviously 1 plus x would go down, 1 would remain as it is, and now there would be a differentiation of 1 plus x again towards the numerator side, and that is nothing but 1. That is nothing but 1. And now you are going to feed limit x tends to 0. Easily you would be getting the answer as e to the power of 1. E to the power of 1. There could be the second methodology to solve this problem out. Many of the students do use that methodology. What it is? Let's take, it has been y, but it has been y. And again, after taking the log natural it had been limit x tends to 0, 1 upon x ln of 1 plus x. Now around x is equals to 0, you can take the Taylor series expansion of ln 1 plus of x. Ln 1 plus of x. May I know what used to be the Taylor series expansion? Once we'll go into the detailed study of the Taylor series expansion, we would be discussing about this problem into the great detail. 1 upon x would remain as it is. You would be having x minus minus minus. Anyways, once you'll see this problem carefully, you will get to know you would have x which has been raised to power 1, and then you would be having x square, x cube, x4, so on and so forth. So once you divide each and individual terms with respect to x, this factor becomes 1 and the remaining factor would have at least one component of x, and once we feed x tends to 0, end of the day the result what we get has been 1 and it has been raised to e, so the result is still becomes 1. Result is still becomes 1. Could you understand? So I would expect from each one of you, the student who are not well acquainted with this sort of problem, they can convert the problem into the L hospital rule by taking log natural. Because many of the times you may get stuck on this sort of problem, and that becomes very painful. Yes. In the same sequence, let me move forward. Let me design a next problem. Here the limit x has to tend towards infinity. Let's take the function had been the ratio of two different functions of x, which has been sine of x as well as x. Tell me what would be the best most worth for this given problem. As far as the sine of x is concerned, it has been a continuous throughout its range, as well as the x is concerned, it remains the continuous throughout its range. So rather calculating left hand limit or right hand limit, straight away I can feed x is equals to infinity towards the numerator as well as denominator. As far as the sine of x is concerned, it is an oscillating signal which oscillates between its maximum magnitude to the minimum magnitude. That means until and unless the value of x is not prefixed, you would not be able to get the value of sine x prefixed. So what we are going to do over here, if you feed any of the larger value of sine of x, I will not be able to predict the exact value of sine of x. It would be anywhere in between -1 to plus of 1. And towards denominator side, the x has been moving towards infinity. So once you will take its ratio, the result would be precisely 0. Till this point, probably each and everything must be clear to all of us. Yes. Anyways, I have. Good evening, Himanshu Bharti. Till this point, each and everything must be clear to all of us. In the same sequence, let me do this problem in the different sense. Let's design the third problem, and rather taking limit x tends to 0, I have changed it to the x tends to infinity. The base was 1 plus x, now had been changed to 1 plus of 1 by x, and its exponent was 1 by x, now has been changed to x. Thank you, Himanshu. Thank you, dear. Sir, when you start EMFT? I am not sure, but yes, recording everything is going in parallel. We will plan that. Tell me what would be the best most answer. My dear friends, the basic property has been used. May I know what it is? If you inverse x everywhere, it becomes 1 upon x, it becomes 1 divided by 1 upon x, obviously it becomes x now, and once we inverse even x over here, it becomes 1 upon x is tending towards 0. If 1 upon x is tending towards 0, virtually x is tending towards infinity. So whenever you have the inversal property, over the limit, the result does not change. Earlier also you had the result as E, now also you would be having the result as E. If you want, you can write somewhere here, it's a very important property. Limit x tends to a, f of x is very same as limit x tends to 1 upon a of f of 1 upon x. That means the function had not been changed, only 1 upon x has been fed in place of x. Yes. in place of x. Till this point, each and everything must be clear to all of us. Let me give few number of numericals, and you guys had to give the best most answer for those problems. Let me write the first question. It had been my first question. So whatever the answer you guys are giving, no, just write the first and then answer, second then answer, third then answer. Then only I would be able to connect how much you could understand the basic concept of the limits. Let me take the first question. The problem goes like limit x tends to infinity. Instead this sign of x, let's take, I have taken cos of x divided by of x. That has been my first question. Similarly, let's take the next question. The question has been designed this way. Limit x tends to 0 of sine of ax divided by of x. That would be the second question which you guys had to solve. In the same sequence, let me take the third question. And that has been limit x tends to infinity, x square plus of 2x plus of 2 divided by of x square plus of 3x plus of 4. In the same sequence, let me take the fourth question. And that has been limit x tends to infinity. Let's do one thing. Change it to the x plus 2 divided by of x square plus of 2x plus of 3 In the same sequence, let me take the fifth question. May I know what it had been? It had been limit x tends to infinity. Let's take, it had been x cube plus of 2 divided by of x square plus of 3x plus of 2. Tell me, what are the different answers you will be getting? The same concept would be applied as we have seen earlier. As far as the numerator is concerned, precisely I may not be able to dictate its exact value until and unless the value of x is not known precisely. So it would be anywhere in between -1 to 1. And as the x has been tending towards infinity, towards denominator you would be having infinity, and once you will divide them together, the result would be 0. Yes. Similarly, in this case, what is happening over here? I would be applying the L'Hospital rule, because once I feed the x is equals to 0 towards the numerator and denominator, again it had been a case of indeterminate form of a 0 by 0. I would take its differentiation towards the numerator, which would lead a divided by of cos of ax. Again, I would be feeding x is equals to 0, which would lead this as a cos of 0 itself, and denominator had been 1. So end of the day, the result what we are getting, it had been simply a. Yes. In the same sequence, let me go forward. There are two different possibilities through which this problem could have been smashed. I used to extract the highest degree of the numerator as well as denominator. When we used to have the highest degree of numerator and denominator very same, the result would always be constant. Similarly, if we used to have the degree of denominator is higher than the degree of numerator, the result would always be 0. And if we have the degree of numerator greater than the degree of denominator, the result would always be infinity. You yourself would be able to judge this. See what we can do over here. Once we feed x tends to infinity, definitely this goes becomes infinity by infinity. L'Hospital rule could have been applied. Once we apply the L'Hospital rule, how many times the differentiation has to be made? 2 times. Yes, because any of the x has been left out towards the numerator, what is going to happen? Any of the numerator or denominator would have the x, so definitely it would lead infinity by infinity once again. So how many times the differentiation has been made? 2 times. Once you will make 2 times differentiation, this 2 terms towards numerator as well as denominator is just going to get 0. Because they had been in a power of 1 as well as 0, and once you will take the differentiation 2 times, they would become just 0. So it had been left out with x square, you will take its 2 times differentiation, 2 would come out, and here also 2 would come out. The 2 divided by 2 would be precisely equals to 1. Yes, precisely equals to of 1. Agreed. Similarly here, if you will feed, the value would be 0, and here the value is going to be infinity. Here the value is going to be infinity. Till this point, each and everything must be clear to all of us. My dear friends, my health is not good in today's class, so definitely I had to terminate my video a bit earlier, but still let me have a glance what we exactly wanted to dictate in today's video. In today's video, we were trying to learn few of the important concepts of the limits. We talked about its important properties like their addition, subtraction, multiplication, division or exponent. Even we recalled what are the different indeterminate form which we have seen earlier. We also saw which are the different kinds of the indeterminate form can be dealt with the help of L'Hospital rule, which had been 0 by 0 as well as infinity by infinity, and even with the help of logarithmic function, few of the remaining 5 number of indeterminate form can be represented in form of 0 by 0, infinity by infinity. L'Hospital rule can be applied. With the help of that concept, I got the 2 important questions from where the questions used to come again and again, and similarly we designed around 5 number of questions. Agreed? So this is all in today's video. Probably I would try to have a longer video in tomorrow's class, and we are going to take around 15 number of problems based on the concept of the limit. 15 number of questions from the based on the concept of the limit, and which have come in previous years examination of GATE. And once you are thorough with those 15 number of questions, now I am challenging you, you are going to smash any sort of problem in GATE examination. So this is all about the today's video. We are going to meet with the next video in tomorrow's class at same time 9 p.m. Till then, bye bye, take care, good night.